7.8 goes over factoring polynomials completely. So when we are looking at these types of problems, we're going to start by looking at factoring by grouping. When you're doing these, you're going to follow the same type of factoring by grouping when we solve or when we factored expressions where a was something other than 1. So it's the same concept. However, you want to make sure that it's completely factored. So if you have something like a difference of squares that you can factor some more, you got to make sure that that's factored as well. So if we look at example 1a, we are given x cubed plus 3x squared plus 2x plus 6. Automatically, you know that you're going to factor by grouping because there are 4 terms here. When we factor by grouping, we're going to set parentheses around the first 2 terms, and then we set parentheses around the last 2 terms. From there, we factor out the greatest common factor from each set of parentheses. From the first 2 terms, that x cubed plus 3x squared, our greatest common factor is x squared. From the 2x and the 6, our greatest common factor is 2. So this gives us x squared times whatever's left over, so that's x plus 3, plus 2 times x plus 3. We want the same thing in each parentheses, which we have, so we'll rewrite that x plus 3 as 1, and then we'll form another with the x squared plus 2. You cannot factor that x squared plus 2 any further than you have right now because it's not a difference of squares. First off, there's addition between the 2, so that would completely eliminate that way of factoring. The 2 is also not a perfect square. So again, you cannot factor that any further. You are done with this x plus 3 times x squared plus 2. For example B, we have x squared plus y x squared plus y plus xy. So again, we're going to factor this one by grouping, put parentheses around the first 2 terms, put parentheses around the last 2 terms, factor out your greatest common factor from each set of parentheses. From the first, we don't have anything other than 1. From the second, we have an x. So this is going to turn into 1 times x squared plus y plus x times 1 plus y. Now, when you look at this, your 2 sets of parentheses are not the same. Because they are not the same, we cannot factor with the terms in the order that they are in right now. So we are going to backtrack with all of this and try to rearrange our terms to see if there's any other way that we can factor this by grouping. We know that we don't have any like terms here, so combining like terms is not an option. If we start with that x squared, what other term here has an x? Either the x or the xy. So you want to move that x or you want to move that xy over to be the next term. I'm going to use the x because I also have a y term and I want another y term to match with that one. From here, I'm going to put the xy and then the y. So I line these up, or I order them in order to make sure that my 2 parentheses when I end, bless you, are the same. So if I put parentheses around the first 2 terms and I put parentheses around the last 2 terms, the first 2 terms I'm going to factor out an x. The second 2 terms I factor out a y. From the first set of parentheses we factored out an x, we have x plus 1 left over. From the second set of parentheses we factored out a y, we have x plus 1 left over. Now our 2 parentheses are the same, so we have x plus 1 times x plus y. So sometimes you just have to rearrange those terms to be in an order to where you can actually factor out a greatest common factor from each set of those parentheses that you put in there to give yourself the same exact identical set of parentheses once you factor out the greatest common factor from them. For example C, we have a cubed plus 3a squared plus a plus 3. If we put parentheses around the first 2 terms and then parentheses around the last 2 terms, we can factor out an a squared from the first and a 1 that's positive from the second. This is going to leave us with a squared times a plus 3 plus 1 times a plus 3. Our two parentheses are the same, so we're going to have a plus 3 times a squared plus 1. Again, you cannot continue factoring out that a squared plus 1 because it is not a difference of squares. Difference would mean that there would be subtraction there, and there is addition, so you do not have to factor this any further. You can't. You just have that a plus 3 times a squared plus 1. Example D, we are given y squared plus 2x plus yx plus 2y. If we look at the order of these, if we grouped up the y squared and the 2x, you can't factor anything out from that other than a 1. If you factored out if you grouped up the yx times 2y, you can factor out a y, but that's going to leave you with x plus 2, and that's not going to be the same as the y squared plus 2x. So we do have to rearrange these terms as well. If I'm starting with a y squared, I want my next term to have a y with it. So if I do the 2y, then I have the 2x and the yx. We can group up the first two terms. We can group up the last two terms. Do you have to order them exactly the way I just did? No. If you wanted to do the x squared plus yx plus 2x plus 2y, you could have done that too. It's totally up to you. Okay? The whole idea with these is you to end with the same exact identical set of parentheses once you factor out the greatest common factor between these two. So with the first set of parentheses, I'm going to factor out a y. With the second set of parentheses, I'm going to factor out an x. This is going to leave us with y times y plus 2 plus x times 2 plus y. Now, with this, your y plus 2 is not identical to the 2 plus y, but they are the same terms. They are just not in the same order. So we can rewrite this to be y times y plus 2 plus x times y plus 2. Your two sets of parentheses are the same now, so we have y plus 2 times y plus x. For our next set of examples, we are just factoring completely. With these, regardless of if you have 3 terms, 2 terms, 4 terms, you have to first ask yourself, do I have a greatest common factor that I can factor out first? If the answer to that is yes, factor out the greatest common factor first. It'll just go in front of whatever's left over in parentheses. Whatever you factor out has to stay with what you have. So if you factor out, let's say, like with the first example that we're going to go over here, a 3x, it has to stay in front of the parentheses, and then you need to continuously factor until you can't factor anymore. Once you factor out your greatest common factor, you want to ask yourself, how many terms do I have left over? If I have 2, ask yourself, do I have a difference of squares? If I do, factor it using that method. If I have 3 terms left over, do you have a perfect square trinomial? If the answer is no to that, ask yourself if a is 1. If your answer is no to that, ask yourself, can I multiply a and c to get factors that add up to be b? If your answer is yes to any of those, use those methods. From there, you want to just make sure that everything is completely factored. Sometimes with these, you would be able to factor 3 and 4 times. So you have to make sure that all of your parts of your expression are completely factored. If we look at example 2a, we have 3x cubed plus 6x squared minus 18x. If we look at these, they are all divisible by 3x, so we are going to start this by factoring out a 3x. That 3x is going to go in front, and whatever's left over goes into parentheses. So 3x cubed divided by 3x is x squared. 6x squared divided by 3x is positive 2x. And negative 18x divided by 3x is negative 6. From here, our a is 1, so that coefficient of x squared is 1. find the factors of your negative 6 that add up to be a 2, if possible. Your 6 is 1 and 6, 2 and 3. If we had opposite signs, we can do a negative 1 and a positive 6, as well as a negative 6 and a positive 1. We can do negative 2 and positive 3, or positive 2, negative 3. If we combine these, none of them give us a positive 2. So we cannot factor this any further. You also don't have a perfect square trinomial because you cannot take the square root of that negative 6. So this here that you have, this 3x, it should be an x, I'm sorry, 3x times x squared plus 2x minus 6 is your final answer. For example, B, we have 7x to the 4th power minus 28x squared. So with these two terms, they are both divisible by 7 as well as x squared. So we'll factor out the 7x squared. You have x squared minus 4 left over. Now, you have a binomial that's in those parentheses. Can you take the square root of the first term? Can you take the square root of the second term? Are they separated by subtraction? Yes to all of that. So you have a difference of squares, which means if you take the square root of that x squared, you have an a of x. If you took the square root of that 4, your b is 2. There's a negative in between these, so use a minus b times a plus b in order to factor completely. So that 7x squared is out front. It's got to stay out front. We said that x is a, so that's x minus b, which is 2, times x plus 2. You cannot factor any further from here, so that x squared, or 7x squared times x minus 2 times x plus 2 is your answer. For example, C, we're given 3x cubed minus 12x. Again, we have a binomial. Do you have a greatest common factor that you can factor out? You do. It's 3x. So we're going to have 3x times x squared minus 4. We got that x squared minus 4 again. We know this is a difference of squares. So this is going to factor out even further to be 3x times x minus 2 times x plus 2. For example, D, we have 2y cubed minus 12y squared plus 18y. We are going to factor out a 2y from each of these terms. And this leaves us with 2y times y squared minus 6y plus 9. Our factors of that positive 9 that add up to be a negative 6 are a negative 3 and a negative 3. So this factors out to be a difference, the perfect square trinomial of y minus 3 squared times 2y. If you wanted to write this as 2y times y minus 3 times y minus 3, it is the same exact thing. You could give that as an answer as well. For example, E, we have m cubed minus 2m squared minus 8m. Our greatest common factor that we're factoring out here is just m. So this leaves us with m times m squared minus 2m minus 8. We can find the factors of that negative 8 that add up to be a negative 2. We have 2 and negative 4. So this factors out to be m times m plus 2 times m minus 4. For example 3, we are just solving now by completely factoring. If we look at example A, we have 2x cubed plus 8x squared is equal to 10x. This equation is not equal to 0, and that's what we want to start with. So we're going to move that 10x over by subtracting it from each side. So this gives us 2x cubed plus 8x squared minus 10x is equal to 0. From here, we are going to factor out the greatest common factor from the 2x cubed plus 8x squared minus 10x. We can factor out a 2x from each of these terms. So we're going to have 2x times x squared plus 4x minus 5 is equal to 0. From here, we have a trinomial left over. A is 1. So we want to find the factors of that negative 5 that add up to be a positive 4. If we have negative 1 and positive 5, that gives us a positive 4. So this factors out to be 2x times x minus 1 times x plus 5 is equal to 0. From here, everything is completely factored. So as soon as you get to this part, you're going to do exactly what you did in like a few lessons before this, where things were already factored for you and you're just solving for the variable. So you're going to set each part equal to 0 and solve for each part. That means you have 2x, you set it equal to 0. You have that x minus 1, you set it equal to 0. You have that x plus 5, you set it equal to 0. And you solve for x in all three of these. So the 2x is equal to 0, we divide each side by 2. We get that x is equal to 0. For the x minus 1 is equal to 0, we add the 1 to each side. So we have x is equal to 1. And for x plus 5 is equal to 0, we subtract the 5 from each side and get that x is equal to negative 5 as well. So 3 solutions here, 0, 1, and negative 5. Example B gives us w cubed minus 8w squared plus 16w is equal to 0. You have a greatest common factor from all three of these terms, which is just w. So we factor out the w. We have w squared minus 8w plus 16 is equal to 0. From here, we want to find the factors of that 16 that add up to be negative 8. That gives us negative 4 and negative 4. This is also a perfect square trinomial. So we have w times w minus 4 times w minus 4 is equal to 0. We can set each part equal to 0, so that would be w is equal to 0, w minus 4 is equal to 0, and w minus 4 is equal to 0. Now, that w is equal to 0 is already solved for you, so highlight that one. That's a solution. That w minus 4 is equal to 0, you got to solve that. Move the 4 over, add it to each side. You get that w is equal to positive 4. Now, with that second one, that w minus 4 is equal to 0, you've already solved that, so you do not need to solve it again. You can just give the answers that w is equal to 0 and w is equal to 4. For example C, we have x cubed minus 25x is equal to 0. So we're going to factor out our greatest common factor, which is x. This gives us x times x squared minus 25 is equal to 0. And we can continue factoring this x squared minus 25 by taking the square root of both sides, realizing that there's a negative there, and factoring out to be x minus 5 times x plus 5. So we have a difference of squares there. Remember the x that you factored out originally. This is going to leave us with x is equal to 0, x minus 5 is equal to 0, and x plus 5 is equal to 0. None of these are the same, so we have to solve for all of them. That x is equal to 0, it's already solved for, so if you want to highlight that one now, you can do so. The x minus 5 is equal to 0, add the 5 to both sides. You have x is equal to positive 5. For the x plus 5 is equal to 0, we're going to subtract the 5 from each side, and we get that x is also negative 5. So we have 3 answers for this one, 0, positive 5, and negative 5. For example D, we have x cubed minus 7x squared plus 12x is equal to 0. We'll start this one by factoring out the x. This gives us x times x squared minus 7x plus 12 is equal to 0. Our factors of 12 that add up to be negative 7 are negative 3 and negative 4. So this gives us x times x minus 3 times x minus 4 is equal to 0. From here, we set each part equal to 0, so we have x is equal to 0, x minus 3 is equal to 0, and x minus 4 is equal to 0. We want to add over that 3 to get that x is equal to 3. And we want to add over that 4 to get that x is equal to 4 as well. So we have 3 solutions, 0, 3, and 4 for this one.